ASM distributor means without the ASM system, there is a way to read the SP file. They will read it.
But Oracle's SP file can't go into ASM.
Oracle SP file. In a cluster environment, the database SP file must be there in the shared memory.
P file, yeah.
P file is there in the local drive.
But it does not go to ASM.
P file cannot be there in the SP file is there. At the same time, P file is having the local node is pointing to the SP file is available in the data. So if there is a empty, SP file equals equivalent data. So you are reading P file from the local node. You are pointing to SP file which are in the plus data. Anyway, you will see then the database. Right now we have to install the database. Because if you want to store the package for ASM, our database software database is to install. Okay. So I'll use some numbers and take after software and try to install. By that time you make your database, node 1, node 2, after running. Perfect. If any problem is that you try to do the handle like a stopping CRS, starting CRS, and rebooting the list, just try for the time being. Worst case it's not working, you need to do the rebooting. But first let's say node 1, node 2, okay, do everything. Don't start node number 3. Okay, by that time you can go to services, some video services, just see if the unwanted things are running, maybe some virus scanning, checking for something is running, maybe because of the performance is low. Anything you see in observatory running the simulator. Don't click VMware. VMware will be running, by the automatic stuff. Okay, now, when the disk goes not happen, when the disk crash happens, if there is no hard disk on the disk, yeah, the RPA will automatically perform the rebalancing. In Oracle 10 is rebalancing in the sense it has to recreate the data. Perfectly alright? Okay, for recreating the data, you can say that it will take you 1 day. Yes, you have to wait for 1 day. You can't escape from that. But is it recreating? Yes, it is recreating. Do you want to depend on the hardware? Do you want to depend on the OS? No dependency. Is it affecting the database? Not affecting the database. Are you able to continue the DML operation? Yes, we are able to continue the DML operation. Correct. But some certain transactions are get affected. But it is not affecting the entire application. It is not affecting the availability of the application. Correct. ASM is not a replacement for your traditional backup. Your backups are as usual. Correct. You are taking the backup. But this is what if any media crash is there, what happens? They can take care of it. ASM can transparently do the thing. Now take a small example here. This makes sense actually when a disk crash, other people recreating the data. Take your own time. Makes sense because the data has to be recreated by the disk failure. Right? Take another example here. I'm working on a 10G platform. Right? 10GB data, 10GB data, 10GB data, recreate of all things. By data, everything is working as usual. Everything is fine. Okay. Somebody remove this cable. This is a very often loose contact or some switch happens, some problem is that this is not very often thing. This is actually not every day happens. Okay, so somebody remove the cable or some loose contact or something is there. Or switch issue converted to something like that. Suddenly what happens?
You want to remove this?
Yes, this one does not send the acknowledgement. Gmail will come and make it offline, and the offline disk will be removed from the disk group. So even though the disk is dropped from the disk group, do you have any problem with the physical disk?
No.
You do not have any problem with the disk. Just the physical disk is having how much data?
10 GB.
10 GB, and disk is fully functional, but the controller card is not there. This functional means no crash with the disk. Data is safe. But these people cannot understand if the data crash with the disk or controller card. So what they have done, they removed it. The moment the disk got removed from the disk group, what they will do? Other people do the rebalancing. So 5 GB, taking their own time. Correct. And you are inserting new 6 GB data, 3 GB, 3 GB. These are the new data. 3 GB is the new data. Correct. This is going on. Actually, the data is available. Still available. The database administrator came to know this error within 5 minutes because you know that there is a mechanism. Notification mechanism. Whenever error comes, it will automatically send an SMS or email to the DPA. So I came to know that there is a disk problem. Within 5-10 minutes I came to know. So I came and I seen that it is not a problem with the disk, it is a problem with the mirror control. Correct. Means any control card or something like that. So the major issue. So within 5 or 10 minutes, I came to know that this is what. Correct. You have to look in the alert log file notification. Various mechanisms are available.
So it means that this controller we have this.
Will not you put the controller back to the how can you get access this type of thing? Then it will show you the higher level issues. Correct. Correct. Higher level issues will be there. You are not able to write the write in the disk. This type of thing. You have to collect information from the system team because that cannot do all the things. So somehow the thing is yes the disk is missing. So what is the solution? We have to add the disk back. So you have to go for a new disk, right? There is no problem with the disk. Correct. So only the thing is what you have to connect the cable back. So even though you connect the cable back, the disk will not appear inside, right? The disk is only dropped. So what should I do? I have to add it. Correct. I have to add the disk. So 5 minutes are already over, and I am trying to add the disk. I am typing the command alter disk to group. Add a disk. Which disk? The same disk. You cannot add. Why you cannot add it?
I have a question. See, already we have some session, right? So better to drop and recreate or what?
That's what I'm saying. You are not able to add. You are always once the way. Okay. Right? So you are adding the disk. When you are adding the disk, you are not able to add it. Why? Because this is not a candidate disk. This is a formal disk. What is a formal disk? Some contents are already inside. It's not a candidate. Correct. It's already used with somebody. So what should I do? I have to forward delete the content. Correct. Partitioning. So what you are going to do? 10 GB data stays there, but you are taking it out. Correct. Removing it. After removing the data, again you are adding it. Yes, you could add it. No, it's a new disk. Correct. There is a new disk. Even change here. New disk is the old disk only, but the data is not there. So the moment you add the disk, they will start doing that. This again is yes, new guy is there. Again, what you are going to do? Whatever data you delete, at the same data again you will do the rebalancing. Actually, there is no need of rebalancing 10 GB data. You need to do the rebalancing only for new data, correct? Because the crash happened by 9 o'clock. Okay, this particular scenario, the crash happened by 9 o'clock. Okay, up to 9 o'clock, what was the data you inserted? Those data are saved where? In the system one. After 9 o'clock, I am saying that 10 minutes. Okay, within this 10 minutes, you already done the 6 GB data, correct? So when you are doing the, when you are giving the disk back again, do you want to again process the 10 GB? No need. You have to process only what?
6.
The changes happened after 10 o'clock. Means only the 10 minutes, the 10 MB data, whatever. Okay, for 10 minutes data, you do the rebalance. But all you cannot understand that. Why? Because this is a new disk. What they will do? They will do the rebalancing of the entire data. So if it is a terabyte data, you can see the thing in the real time scenario. Only because of a loose product for 5 minutes or 2 minutes, these people started their own process. They started recreating the data. Isn't it? These people started recreating the data. Whenever somebody coming against the data has to, beautifully. So performance will be highly degraded and this is not a good mechanism to it. So this is for the problem of consistency. That's the reason we are not much recommending ASM in our pregnancy. So you understood the scenario. If it is a disk crash, definitely the data has to be recreated. Correct. But if it's a logical error, there is no need to recreate the entire data. You have to recreate only the data which updated, which are the extents were modified after the failure. Makes sense, correct? But you are not able to do it. Why? Because by that time, these people started the rebalancing and recreation. Why? The disk is already thrown out of the system. This is the problem with what Oracle takes. You understand it here? Okay. If any small programs happen like the switch off control card, these people will do the rebalancing recreation. Correct? So this is very expensive. So we are not much happy with this type of thing. So in Oracle 11, we release 1 onward. There is a new feature called fast mirror resync. There is a new feature from Oracle 11 release 1. Release 2 also the same feature. So this is called as a fast mirror resync. Okay. According to fast mirror resync, you need to set an attribute, distribute attribute. It is called as a disk repair time. Disk underscore repair underscore time. By default this value I think 3 hours. Okay. Default value is 3 hours. But I am going to set it for 10 minutes. If you need this functional resync, your ASM compatibility should be 11.1. Your RDBMS compatibility should be 11.1. Then only it is available. If you are using ASM compatibility 10.2, which feature is not available? Yes, fast signal racing is not available. Because fast signal racing is available from which version onwards? 11.1. So it is very important thing. You need to ensure that ASM compatibility and RDBMS compatibility is greater or equal to what? 11.1. Okay, that we should set. Okay, so it is called an attributor. ASM compatibility attributor, RDBMS compatibility attributor, and a discrete pattern. I will show you how to change these values. These are the discrete group level attributor, not an ASM parameter. These are the discrete group level attributor. I can create a different discrete group for different attributor. Correct. So I want to make use of the fast signal releasing feature. For that purpose, ASM compatibility 11.1 is equal to 11.1, and you need to type the discrete time. By default it is 3 hours. Now I made it 10 minutes. Just an example. Okay, I configured it 10 minutes is the discrete value. Right? Same thing. 10 GB data available here. 10 GB, 10 GB. Same example. I work with Oracle 11G. What will happen now? Somebody removing that table. Okay, so this cable unplugged. What happened now? Previously what happened? The disk become offline and it will drop down. Now what will happen is the disk become offline, but the disk never dropped from the disk. Okay, for how long? 10 minutes. Right? So how much data load? 10 GB. Even though the disk is not dropping from the disk, but disk is not available, not reachable. So 10 GB data loss is the loss is physically it is not there, isn't it? Okay, so 10 GB data gone and this become offline. The metadata got updated. Yes, the disk is part of the disk group with which stages? Offline stage. But the disk is not out of the disk group or out of the 10 minutes. At the same time, what are the data available here? 10 GB data. These people never recreate. They never do the rebalancing. They never recreate the data. For how long? 10 minutes. So, previous example, they started already, correct? Okay, these people assume that, RBI assumes that, okay, let me wait for 10 minutes. I will do the rebalancing after 10 minutes. Perfectly alright? For 10 minutes, they are not doing any rebalancing. But secondary cookies are available here and there. If they want using the secondary, they can say the primary, correct? They are not doing it. How long? 10 minutes. Okay, now, somebody types in the command select from EMB. When they are typing select from EMB, the primary copy, he is looking for a primary copy. Was not the primary copy? In that first register. Is it available? No. It's not available. But the previous case, if it is not available, no problem. After some time you will get it. How long? You will recreate it. Now here not recreate. So what happens in Oracle 11G? Even though the primary copies are not available, using the secondary copy, we can satisfy them. Means you are able to read another copy as well. But preference always goes to primary copy. In case if the primary copy is not available, you can read its copy, secondary copy. So whenever anybody is trying to read the data, if the primary copy is not available, what you can do? Those query can be satisfied by using the secondary copy. Customers are very happy. Correct? No problem. At the same time, okay, no rebalancing, no burden out. At the same time, as usual, I'm going to make a 9 AM a crash happen. I'm going to insert 6 GB data. 6 GB is the new data. So when you are inserting the 6 GB data, 3 GB, 3 GB. Okay, you will write in the second, third, including primary copy and secondary copy. Everything as usual. This can continue for 10 minutes. Within 10 minutes, as the DJI came to the problem. Example, because this is the buffer time. Okay, let me take it 2 hours, 3 hours. What are the period? So I came to know there is an issue. Immediately I came and I identified the issue. I connected and made it offline. Online. Everyone, you don't have to add the disk. Why? If the disk is already available with the 10 GB data, correct? So what time the disk will become offline? 9 AM. Correct? So I am making it online by 9:05. 9:05 I made it online. 9 AM become offline. 9:05 what happened? Okay, I made it online. Correct? What happened now? The moment you are taking it online, this people came to know, okay, this day came out, but he is not a new guy. Okay, so what I will assume? You went offline by 9 AM in the morning. Up to 9 AM in the morning, whatever changes happen, those changes definitely will give. Correct? So we have to rebalance only with data. Only the changes happen after the crash. So according to 5 minutes data. So that 5 minutes data, 6 GB. Previously you are going to rebalance 10 plus 6, correct? Now only 2 GB, 6 GB data. So they will take a 2 GB. This is for one thing, for instance, fast user.
But till the time it was down, 6 GB was being distributed among 2 or 3 groups, right? When it comes up, when this one comes up, then suppose 2 GB data has already been written into this 2 and this 3. So there 4 GB will be shared among 3 groups. Means the 6 GB data that has come while this one got down.
Total amount of data is 6 GB. Right. So 6 GB is written in the second is the third. Whenever they are coming 6 divided by 3. 2 like that. Correct. The amount of data will be rebalanced is very less. Means only the changes you need to rebalance. Makes sense actually, correct? What if I am not doing anything within 10 minutes? Nothing. I am not doing any activity within 10 minutes. I have to get a disk online within 10 minutes.
Right.
Now you are saying I am not doing anything. So if I am not doing any activity within particular time, what happens? After 10 minutes, the GMOD will come and drop it. Okay. Correct. You know that. Now the disk got dropped, what happens? It is exactly just like a 10 GB. Other people will say that, okay, let us create that. So whatever data was there inside it, that data has to be recreated. New data also has to be there. Next time we are adding, it's a new disk. So any data has to be the same example like an in 10 GB how we have. So this value here is a proper value because it's a buffer size for us for what purpose? For troubleshooting. Okay. So within the segment, they can survive using the secondary copies. They can use the secondary copies anyway. Correct? For reading operation. Correct?
Setting a higher value is a good.
Setting a higher value, setting a very big value is a bottleneck. Why? Because they have to keep track of the changes, which are the extents got modified after the failure. Correct? They have to keep track of each and every extent. So it's a metadata keeping what is very difficult task. Correct? And again, you are continuously do this for one more failure, it is not a problem. Correct? So that is it's not a good idea to increase the value considerably. It's not a good idea to reduce the value because it's up to us. Okay, how long you can tolerate? It depends on the transaction, depends on the what type of variance and what. But it is not possible. 10 minutes I already expected and 90 minutes I am saying that sorry, it's a mistake. I want to make it 20 minutes. You can make it 20 minutes. That's never expected. But after 10 minutes it will stop. Correct. So we have to set a problem.
What happens in case of data is
Which data?
0, 60, data coming, let's say 60,
Anything delete insert update, never mind that. Which are the extents got changed?
will it do rebalancing or will it just remove the whatever data what is from the technique of
See, the thing is, you are saying this way, one block, another block, correct? Now data is available, row number 1 is available here. Correct? What are you going to do now? You are going to delete it. So row number 1 is deleted. Whenever the row number 1 deletes,
this is for the secondary copy of whatever.
This secondary copy. If it is a secondary copy, if they want to do the DML operation, what they have to do? They have to get it as a primary copy. Correct? DML operation, they are not doing the secondary copy. Correct? So what happens? Your primary copy available here, this is secondary copy. Primary copy is not available. So what happens in secondary copy? You are going to do some reading operation. So what happens? This will be the primary and the secondary will be written summary. Correct? So 1 number 1 and 1 number 1. Now what you have done? You updated this value or delete the record, this is the record. So the block error contains it's a modification, it's a modification. It's a new extent, correct? It's a modification, but we have 10 minutes left, right? We have a modification. Modification cannot be done in a secondary copy. Secondary copy is for what purpose? Your reading operation. So whenever you are going to do any DML operation, what happens? They will automatically send to as a primary copy. At the same time, it's not a rebalancing. They are not doing the rebalancing actually, correct? So whenever you are going to make a modification of block number 1, they will throw the block number 1. Correct? So what is the other? So what? Yeah, another user. Okay. So what happens? They are allowing you. Otherwise, what happens? If you are allowing me to do the modification here, after doing the modification, if you D2 go crash, what happens? I have some other response. Data loss will be there. So for that purpose, whenever you are going to make it a GML operation, immediately they will create what? Primary and secondary for that. Okay, so now they will consider 9 o'clock, block number 10 was changed. So whenever they are writing the math, so they will say that block number 1 got modified. That is what a changed block or changed extender. Correct? Fine. Then when the disk is coming up, what will happen? Like that, 3 blocks got modified. Now 3 blocks got modified. These 3 blocks are handled by who? These two. Correct. Now what happens? This day coming up. When this thing coming up, what they identified? Up to 9 o'clock, everything is perfect. After 9 o'clock, 3 blocks got modified. So what happens in this case? 1 block, 1 block, 1 block. Example I am saying that. They will take out. Because it's a change in extender. Correct. In a EML operation, it will modify the block. So actually what they are going to do, after the crash, they are going to monitor which are the extents got modified. Only the modified extents has to be rebalanced. Only the modified extent has to be rebalanced. This is the way they are going to keep that.
So you mean the secondary copy will become primary copy, and it will also create a secondary copy.
It's not a primary secondary. Whenever they are going to take a modification here, for example, if it is a secondary copy, they will maintain a primary copy. It is not a turn to the primary copy. They will maintain a primary copy, just like how we maintain it. Correct? It's a clone copy actually. Then they will allow the changes were in the primary copy. Okay, then it will update secondary. Synchronization. They will do.
Let's say again, 10 minutes after that, this is not come. So you will
Absolutely. They have to do the entire defense. But what are the modifications you will do then? Modification. Otherwise it will be more, risky, isn't it? For example, if you have a 3 surviving, if you are able to make the modification to secondary copy, what if the second is also getting missing? Primary only missed. You have a secondary here.
You need me not to do this.
That's what I am saying. It's a modification. For a select operation, okay, at least you can survive. For modification, you have to maintain it. Correct? So they will maintain it. So whenever you are going for a DML operation, what they will do? They will take care of it. Correct? But previously, what happening? Previously, the NDA Karabe data, what they are going to do? They will be do the rebalancing. Correct? Okay. Actually, the concept here is you do delete the insert, update, what are the things? They will consider this will be making a modification. Any modification you made, any DML operation you made, the DML operation, the changes has to be rebalanced. What are the changes before that? Those things don't need to rebalance. Why? It is already available there. Available in
Those
the
blocks will be there. Whatever is there, only those blocks will be there. Even though I am
saying blocks, in that case an AU. Group of blocks, correct? Extents. The extents are going to rebalance. By default, the extent size is equal to AU size.
I have a question regarding block rebalancing.
Block rebalancing. That is similar to rebalancing.
Talking about the DML part, suppose 2 blocks are changed. So once we are waiting in D2, this 2 same copy we are putting in S3. So once this one comes up, how we are total 4.
You don't take a single block. What is the size of a block? The block is having 2K. Yeah, no, what 8K? 8K block is not eligible for splicing, isn't it? If you want to do the splicing, minimum size should be 1 MB. No, so how we can say that you do the splicing and isn't it?
So it will rebalancing will not happen in this case.
No, rebalancing is what is the rebalancing? Rebalancing means if these two people, see, previously 10 GB available here, now 10 GB, 10 GB. Whenever any crash happens, this people 10 GB, 10 GB. And you made a change 6 GB. So total how much change you made? 6 GB. That is what I told you, DML, block. The block was modified, DML.
I have only 2K. I don't have
So you have how much change you made? 2K change you made. So you made a 2K change and a 2K change. So this is what your change you made. Okay. So how does this primary code get able to do that?
These are primary,
Okay, some primary, some secondary. Correct. Okay, fine. This is what your primary, this is what the secondary. If it comes here, correct. So whenever the risk comes up, you have to give some load here. Correct. How we are going to give the load here? You cannot give the load here, correct? Because if you want to give some task to him, how you are going to give the task? You are going to write in the form of KU, allocated unit. So here one is. So if I want to go for in this case, if I want to go for a lower price, just we have a mechanism. That's what I only told you. There is something called a use.
6 GB होगा.
So by default, how they are going to do? 1 MB, 1 MB election. Means if I'm writing 1 MB in one disk, this 1 MB is mirrored. Correct? Okay. If you're writing 3 MB, 1 MB, 1 MB, 1 MB, they are going to balance. Correct? No? But what if you can write only 1 MB? I have 3 disks. I have 3 disks. I have only one pen. Nothing else. I got 3 disks. I am inserting 1 MB data. What is that? I have 3 disks. I am inserting 3 GB data. So 3 MB data. What is that? 1 MB, 1 MB, 1 MB. 5 MB. Then what are the data written here? 1 MB, 1 MB, 5 MB, 6 MB, complete rebalancing, correct? What are the data written here? Mirroring here. Mirroring here, mirroring here. So 2 MB, correct? Now I am writing 1 MB data, only 1 MB. First discuss, 3 discuss. I am writing only 1 MB. What is writing? Do you want to say that 1 MB divided by 3? No, because minimum writing is 1 MB. So what is like any one of them? Just for discussion, first discuss. That's a primary copy. What is secondary copy? Right? Any one of the. You understand that? So minimum, if you want to do the typing, the size should be what? 1 MB, no? So you can go for 2 MB. What will happen? 1 MB first disk, 1 MB second disk, primary. Correct? So this primary, secondary, this third disk, nothing to write here. Correct? This is what the primary shows. But if you think 1 MB also I have to split it. I have to do the splitting. Yes, we can do it. For that purpose, we have some algorithm. Just that algorithm, you have to see that. You understand the concept? Okay. So they are going to span the data in the form of AUs, allocation unit. So allocation unit is the smallest unit which are going to define how the data is going to write across different disks. Correct? So any AU size you mentioned, what will they do? They will try to maintain what that AU size. So if the data size is greater than AU size, then only writing coming in the picture. Correct? If the data size is less than AU size, writing is not there, but mirroring is there. True. Clear the answer. So this is the way. So now you understood what is the fast mirror finger. Fast mirror is here. So when a disk comes up, what happens? When a disk becomes offline, it will immediately not show up. Correct. So we have some buffer time in front of us for one person. So why is Oracle MVC coming with which feature? Yeah, this is a fast mirror rating is by default. Only the thing is the compatibility should be. What is this compatibility? ASM compatibility, RDBMS compatibility. 11. RDBMS compatibility cannot be greater than ASM compatibility. Means if I am working with the ASM compatibility 11.1, I cannot put my data base 11.2 inside. Correct. At the same time, I am working on the 10G. Right? If I want to support Oracle 10G, my ASM compatibility should be what? 10G. So what I can do? You can create a different disk group. I am working Oracle 11G link to version. Okay. I want to support lowest compatibility. I want to support the highest compatibility. So what I can do? We can create a different disk group with a different compatibility. So one disk group I am creating ASM compatibility 11.2, RDBMS compatibility 11.2. What do you say that? All the features offered by the ASMs are available. At the same time, it can support which version of the database? 11.2 database. Correct. And again, I am creating one more disk group. In that disk group, I am going to configure ASM compatibility equal to 10.2, RDBMS compatibility equal to 10.2. So in that case, what happens? ASM compatibility 10.2 means you are conforming with all the features. So what are the features I discussed here? These features will not be applicable for which disk group? That particular disk group. At the same time, which database is happily running there? 10K database is happily running there. Correct. So the compatibility we have to specify according to that. Now, the moment you are going backward, you have to compromise with all the features, new features. Correct. So we have two things here. ASM compatibility and RDBMS compatibility. And RDBMS compatibility cannot be higher than ASM compatibility. And this is not a parameter. These are disk group attributes. When I am creating a disk group, we can create attributes. So you can create the n number of disk group. Theoretically, we can create a 63 disk groups in Oracle. So you can create a 63 disk group. So when you are creating a disk group, we can specify what should be the compatibility, individual compatibility, individual, RDBMS, ASM, everything you can define. Clear? Don't have to wait because of ASM. SP5. These are not the SP5. These are not the parameters. Okay. But one thing I told you is the ASM power level. That's the parameter. This is not a parameter. These are the disk group attributes. There is a special command for changing the disk group attribute.
These things again go to SPF file and
No, it's storing the metadata.
change this.
The metadata.
মানে existing data को total rebalance rebalance
We can also
Metadata. You can access the metadata. Yes, views are available. You can access the metadata. Views are available. Many views are available. Okay, there is a command called kfet. ASM kfet utility. Choose the utility category. Or the utility.
Can I make one of the disk group offline? It was having compatibility of 10G. And then can I implement FM after bringing the compatibility level? And I can bring it up again.
What is that?
One of the disk groups I set to 10G compatibility. There is no FMR. So I purposefully made it offline. Then while bringing it up, I will change the attribute to have the compatibility of FMR. Then I can bring it up.
You can anytime, disk group compatibility, this compatibility can be changed anytime, no issues. Okay, but the AU size cannot change. Once you define the AU size, you cannot. But you can decide what should be the AU size. I can create different disk group with a different AU size. But once you type that, but a disk group, this type of compatibility anytime, online, we can do it. No worry. Clear this one? So we have seen this ASM instance and the disk and disk group, ASM metadata. What is the ASM metadata actually? The information regarding the data. ASM metadata initially available in the memory, but physically written in the disk group. I told you that some pages is coming from the disk group. Correct. So some pages is coming from the disk group for writing the metadata. So physically it is written in the disk group, but logically memory is available in the memory. Which memory?
So we need to mirror. We need to share mirror into this DC.
Which one?
This metadata.
Metadata stands for all the disk.
Same.
For the metadata also there is a pricing mirroring. It has to protect that.
Then metadata.
It has to do the mirroring. So the mirroring capability is applicable for the metadata as well. So the metadata is not writing a single disk. It is written across all this.
Means if you are putting for videos and all, it will spread over.
It has to spread across all this. You understand that? It's just like you are writing a control file. For a control file, something like a metadata. You are putting a data dictionary for a metadata. The data dictionary is spread across all the three disks. Correct? Same way, the ASM metadata also writing across all the disks. But that writing also is not like the other thing. They are writing also in the header part. Disk header. So they will be returning some place in the disk header for writing what? Writing all the metadata. Yes.
Suppose the disk group fails because of the cable got disconnected.
Disk fails.
Disk fails. At that time the disk repair time was 10 minutes.
I already explained that.
So I couldn't do that, so can I make it 20 and wait?
You can make it 20. I told you that you can make it 20. But if you are making it 20, no use. Because, take an example, disk one become offline. The disk has to be make it online within 10 minutes. 8th minute I am thinking, sorry, again I have to go to the shop and buy a new card. Okay, so it will take us 15 minutes. Correct. So I want to make it 30 minutes. So now I am typing a command because ASM everything is available. So I am typing a command and changing it. There is a command available. Alpha disk group set attribute and changing 30 minutes. When I am changing the 30 minutes, that 30 minutes is applicable for display and display. All the disks which are surviving the disk group, for them that is applicable. But for him it is not applicable. For him still it is 10 minutes. The next 10 minutes is different. But if this thing become offline, then it becomes. So you cannot replicate. You can change, I agree that, you can change. But that cannot be effective for whom? Say over already failed, cannot somebody already failed. Correct. For example, 10th standard, the passing marks. Okay, the passing is 50%. So So this year it is 20%, or this year it is 30%. So one day got only 29%. Failure. Correct, no? You only fail. Next year there is a new rule. Okay, only you will 10%. You can say that they have to pass this. This year you already failed, but the next year onwards they will start, even though they got up to 10%. Okay, so that's the same way.
Operation success, patient died.
So we have to change, see this level structure. So shade pool is for all of us. ASM method. Your ASM method writing the shade pool, but physically what is considered? So whenever starting your ASM instance taking all the metadata from this group and keeping the shade pool in the shade pool. Whenever you are making any changes, initially the changes are happening in the shade pool. Where it is writing? Shade pool is not containing any library cache, data dictionary. As you say in the data dictionary. No, there is no library cache, there is no data dictionary cache. These type of things are not there in ASM. Correct? So shade pool is only for metadata. ASM cache, other memory area, ASM cache. I told you that whenever a disk becomes crashed, the data is available here, it has to be rebalanced. What is the rebalance? You have to take some data from the, you have to give to him. Correct? No? Means there is some data interchangeable. Correct? Some data has to be copied here and there. Correct? You have to replace the data, you have to copy the data from here and there. You can't copy the data from a disk to disk. You cannot do it. So you need some amount of memory. Correct? So for rebalancing operation, you will make use of which memory? ASM. So ASM cache is for a rebalancing operation. So whenever there is an ASM rebalancing, they will make use of which memory? ASM cache, they will make use of it. Right? So we have a large pool. What's the purpose of the large pool in database instance? In database instance, large pool? Any armament backups or shared term architecture, the UGA coming into picture, parallel operation, correct? So whenever any additional memory requirement need, that will be satisfied by using memory large pool in database instance, correct? Same way here also, whenever there is an additional memory requirement need, that will be satisfied by using large pool. Here additional requirement means not the armament backup server. Here additional memory requirement means whenever you are going for a parallel operation, the parallel operation need what? Need some memory area. So which memory area they will consume? They will consume large pool. So whenever any parallelism coming in the picture, starting multiple ARB is nothing but a parallelism, correct? Okay, so whenever any parallelism coming in the picture, you will make use of which memory area? Large pool. Means we can convert this way, any additional memory requirement, you will be making use of which memory area? Large pool. So these are three memory area available in ASM. Oracle 11g release 2 onwards, you no need to maintain the memory manually because automatic memory management is applicable. Which parameter? Memory target. Memory target parameter. So minimum we need your memory underscore target minimum we need 256 MB minimum. So the minimum requirement for ASM 11g release 2 is 256 MB. Okay, and this memory you have to convert manually because it is completely automated. What is automated? The internal components can automatically grow and automatically shrink depends on the requirement. Why? Because one single parameter controlling the memory. You know that in Oracle 10g automatic shared memory management, Oracle 11g automatic memory management, correct? AMM, PGA can grow automatically, SGA can grow automatically. The same concept, even though there is no PGA, there is no SGA, the internal component can grow automatically, they can shrink automatically. The value determined, but the value is 256 minimum. Okay. So this is the way you can manage. So you don't have to play with the memory in any way because auto. Free memory, no, last one. Yeah, free memory means you will be, for example, if you are giving 256 MB, take an example. Of course, free memory will be there. Why? If I am giving 250, for example, if I am starting with a 200 MB, okay, according to memory target development, the memory will go automatically, shrink automatically. So my shared pool is using 50 MB and this guy using only 50 MB, this guy using only 50 MB. How much memory you like there? 150. What is free memory? That 50 MB can be used for what purpose? Future? No. parsing syntax cache. Syntax cache is not directly done by your library cache. Syntax cache is done by using what? Syntax cache is actually using that you have a private SQL area, correct? Where is the private SQL area available? So you know that whenever you are executing any query, you have to go for a private SQL area, correct? Where is available?
Shared.
No, private SQL area is not in the shared pool. Correct. But in ASM there is no PCA. But definitely they will be using the memory area for that, correct? So what we will do, in ASM there will be some separated memory area they are reserving. For what purpose? Doing all these activities like keeping all the memory, reloading information like that, and so many things. So they will be keeping some additional memory area inside. We can't call it as a PCA. Okay, yeah, some certain memory will be available inside. But we can't say that like library cache alone, it is not a document or we cannot see such a memory. But definitely, some memory area, some parsing has to be taken care of. Correct? All the parsing has to be taken care. Whatever activity are going to do it in ASM, everything has to be taken care. But that is implicitly ASM taking. But ASM doesn't have any metadata. ASM doesn't have a data history. ASM doesn't have any optimal sort of things. But internally, that will be taken care.
And the ASM cache will also have iterations. ASM cache. That also have iterations.
No, but the iteration, definitely the iteration theoretically we can say iteration. What is iteration?
I mean, the size we are designing for the parameter to memory target is sufficient for ASM model.
That matters. That matters because that statistics are not you can see from the Vedor ASM use. The Vedor ASM static tables are available. Also, you can see that how much memory utilized, whether it is running out of space or not. Of course, we never say that no tuning required for this. We never say that. We need a tuning. So what will happen? Memory target we have to configure a good value. Correct. Accordingly, we use the first one. But you know that the consider just like a DB instance because all the activities will be happening there. Database information. Correct. Here only the ASM less activities. So no such tuning required in the memory of ASM. Tuning is required only there. IO part. ASM tuning required only the IO part. Correct. Input output operation. But the memory part is not much because your data blocks are not fetching here. Your playing is only what metadata. Your data blocks are fetching into the DB instance. So you need to tune what? DB instance you need to tune. At the same time, whenever this is coming here and reading the data, I am not able to get the data properly. Maybe something IO issue because of the ASM instance. Yeah. So IO level tuning we did. But at memory level tuning no. Memory tuning you did the DB. But of course we have to ensure that we have enough memory.
The database size. This will not matter.
No matter. Database size can be anything, no matter. Okay, this can be different. N number of databases can use the same memory area, but that matters here. Database size, or number of databases, everything matters here. How many disks, what is the size of the disk group, when the number of disks are increasing, the metadata also will increase. Accordingly, what we will do go for some.
Since there is no data dictionary, but still the metadata is available about the ASM instance and disk groups and all. But we have to access only using VDALA or there is any fixed tables like DB and this.
Of course, there are some fixed tables. What is fixed table? Nothing like that. Extra. Okay. You don't have data dictionary tables are not available. DBA, user, these are data dictionary, these are not available. So only you have a K dollar. X dollar, B dollar, GB dollar.
So once the ASM instance is powered off, then it's gone. So again from the metadata it has to be built.
Yeah. Okay, metadata means basic information will be the metadata. For example, if I measure the 10 disk, when you are firing a video disk group, it will show you 10 disks. Even though you shut down and start it also, it will be shown 10 disks. Correct? Because that will collect from the metadata. So metadata is the only one repository for this information. Correct. There is no any data dictionary table where it is available. Correct. So for troubleshooting purpose, we can use the kernel table. Correct. Kernel tables are available, kernel level. But that's what advanced troubleshooting and we can do it using kernel. But there is no any data dictionary. No need. We are not playing with any type of data here. Correct. Only metadata we are. Metadata we have in that. Okay. So the memory, you understood? Various memory, shared pool, ASM cache, large pool, fine. And RBL background process stands for what? Rebalancing. What is the proper? Coordinating the rebalancing. Okay, coordinating the rebalancing activity done by the RBL, but the real rebalancing done by who? ARBL. How many ARBL can start? 11. Okay, 1 to 11 ARBL. Which parameter? A is the power for limit parameter. Correct. G1 already discussed. What is that G1? Making the disk offline. What is the disk group? Making it offline and dropping the disk from the disk group. Correct. Okay, so that will be taken care of by the G1. And PZ9N. The PZ9N background process is responsible for populating GV donor views in a cluster environment. What is GV donor view? Global view. So the ASM GV donor view populated by whom? Populated by PZ9N background. Okay.
Where does it come?
GV donor view. Global view. Populating the GV donor view.
Populate $1 views in.
So, like you have, whenever you want to go and look, you can see. Same like GV donor views also.
GV donor view will contain the content of across all the nodes. So if you want to see the content of the GV donor, you publish GV donor content. The content populated by whom? Mark the background process, MARK background process. Mark the background process responsible for making an allocation unit in state. What do you mean state? Not being used, not used. Means something like obsolete, something like that. Correct? So some allocation unit. For example, whenever a disk becomes offline, okay, what it has to do? The allocation unit which is written in the disk, it has to say that these are the states. Correct? They have to update the state status. Whenever any metadata, updating the new value, the old information has to update the state status. Okay, so they have to update it. These are the obsolete data, these are the new data. So whenever any changes happen in the AU standard, the allocation unit has to mark it as a state, means don't use. That will be taken care of by whom? That will be taken care of by the mark background. MARK. Okay, and other background process, one more background you can see ONNN. 001, 002, something like that. ONN background process. ONN background process is responsible for inter-instance communication. What do you mean by that? In a cluster environment, ASM is running across. ASM is running across. All the nodes. Correct. So what they have to do? They have to communicate each other. Correct. So inter-instance communication will be done by whom? Done by ONN. Because they have to share the information. Correct. Whenever any rebalancing is happening, whenever any error is happening, they have to share it. Some information they have to share it. So they will take care of what point. ASM instance is communicating inter-instance communication. The ASM instance they are communicating each other through ONN.
ASM instance.
Mark is marking your allocation with the state status. Same.
ASM instance is only one.
Every node is not
Again, mirroring everything inside and every node is separate.
Yeah, number of processes, current processes.
Yes, suppose I have a
You are talking about which parameter? Process parameter. What is the process parameter in database?
number of connections.
No, it's not about that.
Number of processes.
Number of each process. The number of process, use the process plus background process. Correct. Means use the process SP plus background process. Take an example. In my database instance, there are 20 background processes. Just an example. N number of background processes. Just an example. There are 20 background processes in my database. Process equal to I given 50. So what do you mean by that? We can start only 50, so 30 dedicated. Correct. Because 30 plus 20. Correct. Same constructor. Okay, but there's the difference. You cannot create a user account in there. So in ASM, always you will be connecting as which user? Sys. Correct. So whenever I am connecting as a sys user, one server process. Whenever you are connecting as a sys user, another server process. Correct. That's a foreground process. At the same time, these processes will run. So this background process plus foreground process. Correct. that is equal to 4. So in an ASM, the process parameter can be varied as y. Only will connect with ASM, only will be connected. Only whoever want to manage the ASM, they
so it is not only one way.
that is not a connection. That is true this way. Whenever they are going to come and read, this is the way we do it. Database instance, the process parameter which are going to give that is for database. How many people can connect the database, including the background process? Whenever you are going to read anything, you are coming here and reading database. Correct? You never establish any connection with ASM. If user one connected with the DB instance, you never connect with the ASM. Whenever I have filed the command select after near B, what happens? My server process which resides in the DB instance reading the data from the ASM disk for me. Correct? No? So you are not establishing a session with who? ASM. Okay. ASM instance is very different. Right? Any changes happening, these people will coordinate. There are some background process I told you. They will communicate and they will coordinate. See, since it is the same binary, Oracle binary and the Oracle database binary and ASM binary, what happens? All the background process, all the files, all the parameters will be common. No? But some parameters there is no use where in ASM. Same way, those parameters no use in the database. Some background process running in the database no use in ASM. Some background process running in ASM no use in. But you can see all the background process here and there. Because why? Software is staying only, correct? The software binary you are using is same, but at least here you have the integrated infrastructure. Previously the same binary, correct? So that's the logic, sir. But if the background process they don't need to do anything, they will go for a sleep. They never do anything, correct? You can see that. How do you know that whether background process started or not? I want to know that whether background process started or not. These are the BS factors. Read order BC process, correct? That's the viewpoint of read order BC process. Read order BC process. Yes, I have to show you. Okay, but read order BC process. In the database, I want to, how many DB writer can start in Oracle 11G? Please do. How many DB writer? Database writer.
69.
Oracle 9,
10.
Oracle 9, how many DB writer?
8.
Oracle 10G?
10.
Oracle 10G? Oracle 9, you can start 10 DB writer.
And minus 1.
Okay, 10 DB writer. Okay, 10. Right? Oracle 9. Oracle 10G, you can start 20 DB writer. 20. Oracle 11G, release 2, you can start 36 DB writer. Right? How many archiver you can start? 11G. Archiver. 30. 30. So 30 archiver background process you can start in Oracle 11G. 10. Previous also 10. 10. And how many archive definitely you mentioned?
+1. -1.
Archive destination in Oracle 11G you can go for a 31 remote archiving, 1 local archiving. 1 archiving local means you are flashing for area. 31 archiving remote means standby. So how many standby you can configure? 31 standby you can configure. 31 standby server you can configure. You can shift the archive 31 remote location.
Is there any formula or what?
The what Oracle coming with that. Not a formula, they come with the product. So we have seen the redundancy, we have seen memory, background process we have seen, allocation we have seen, and the fast memory.
We said reading from the video for whom we can read.
He is not reading the video. He operates in the content in the video.
Reading into video.
See, when you are typing something like a TV dot, you are expecting something in front of you. Correct? Those values operated by GB dot. Sorry, please then
somebody should go and put the value of this difference as value of the schematic. How create like
normal data is how we are getting. Normal data is normal data. You have a dictionary, you have a control file, you have a SGA, correct? They can give the information in front of you, correct? You will get here nothing for you, correct? The information always available in the metadata. From the metadata, the information has to be given to you. Who can do it, sir? Please let my so your metadata available there. The value you are looking for is available in the metadata. Somebody has to get the data from the metadata and give to you. Because you don't have a control file, you don't have an SDA, correct? So who will take care of it, sir? Your please let my Okay. Now, algorithm. Okay.
Algorithm is composition of some attributes or what? Algorithm.
It's an attribute.
Composition of.
Yeah, it's an attribute. You can change the algorithm. Nothing but an attribute. It's an attribute. Okay. There are two types of algorithm here. Okay. We have in ASR, we have a post-price algorithm and fine-grained algorithm. Okay. Post price and time period. Okay, this algorithm for pricing. How we are going to do the pricing? For that purpose, we have two types of algorithms: post pricing and a time period. Post price algorithm means price ratio always equal to AU size. Right. Your price ratio always will be equal to AU. I will explain it. If I want to write a 3 MB data, what is the 3 disk? 1 MB, 1 MB. If I am writing 2 MB data, then I will write only 2 disks. If I am writing 1 MB data, I will write only 1 disk. Because it's equal to what? Equal to AU size. If the AU size is 2 MB, what happens? If I am writing 4 MB data, 2 MB, 2 MB. Correct. So what are the size of, why is not 1 MB, but what are the size of the AU size? That is the amount of data is going to write. For example, if you have a 16 MB, when they are writing 16 MB in one disk, 16 MB other disk, 16 MB other disk. That is what is writing. Okay, so the strike ratio is exactly same as the AU size. We are talking about what? We are talking about the course price. Correct. So, 3 MB. You can't go for 3 MB. Oh, sorry, the data. That 2 MB, 1 MB. 2 MB, 1. Correct, no? It is right. But AU size you cannot go for 3. Correct. It will right like that. Correct. But you are right, no? AU size. Price ratio always will be, because always you can't go always you cannot go for multiplication of the AU data. I can't ask the customer whether inserting the data multiplied by 2 or multiplied by 2. I cannot do like that. No? They will insert the data, but the calculation is done here. How about this? This kind of
CMP data means like 20, 20, 20.
60 MB. How many disks you have? 3 disks. We have 3 disks. Fine.
Depend on the use.
Okay. How many data?
60 MB.
60 MB the data size. Correct.
1 MB.
Data 20, 20, 20, 20.
They are going to write 1 MB, 1 MB, 1 MB. Next 1 MB, 1 MB, 1 MB, 1 MB, 1 MB, 1 MB. That is what writing.
20, 20.
But I was not writing. You are not writing 20 here, 20 here, 20 here. Not like that. 1 MB, 1 MB is parallel. Next 1 MB, next 1 MB, next 1 MB. Finally 20. So the price ratio means the header of each and every disk simultaneously writing how much data? 1 MB. Writing. Correct. Then next 1 MB, next 1 MB. So these are the basic facts. Okay. Now we have a post price algorithm. Now take a small example here. Just take a small example. 3 disk I have, and there is a data file which is having 30 MB data file. What will happen?
30 MB.
30 MB data file. 3 disk. 1 like that. Finally 10 MB, 10 MB, 10 MB. Perfectly alright. So it makes sense. So 1 MB, 1 MB they are writing. They can write it. Correct. Okay. 30 may have given it. It can be 31 also. Correct. It can be 31.5 also.
One will have a
correct. Yeah. Lesser amount of data. Fine. So this is the way. Now take an example, I am writing my control file. When I am writing my control file size is around 200 KB. Small binary file, correct? Example. So my control file is 200 KB. So what are these cases? It will write only in music file. It will write, definitely write. It will write in one disk. Okay, AU size is 1 MB.
So it's
So what happens? You can write 1 MB. So any one of that disk is going to write 200 KB. At the same time, wherever it is primary, secondary will be maintained. Correct? Okay. But I am looking for 200 KB size. I know that 200 KB will not be written because minimum unit 1 MB. But I am interested to do striping for 200 KB as well. Correct. So, what do you mean by that? I want to go for a lower stripe ratio, especially for some small binary files. You see, just take an example. If you are writing the 200 KB across 3 disks is faster, writing 200 KB in 1 disk is faster. 200 KB data simultaneously writing across 3 disks is faster, writing 1 disk is faster. So definitely writing 200, even though it is 200, even though it is less than 1 MB, still if you are splitting into 3, definitely good performance will be there. But sorry, you cannot do it. Why? Because according to this concept, minimum. According to fine grained thing, you can go for 128.
It is universal or?
So it's already predefined, you don't see. Okay, this you can change that. This you cannot change. 128. So what do you mean by 128? AU size is 1 MB, for example. AU size is 1 MB. Okay, fine grained it is by default 128, correct? 128. So what they will do? Whenever you are using fine grained algorithm, the data they are going to write the first 128, second 128, third 128, then next 128. So always the stripe ratio will be equal to what? Equal to 120.
But if it is writing a huge data, it has to write more things.
We never do this for a data file. Data file always we will use this one. This is for what type of file? By default, control file is fine with the small binary file. But still, I want to make it so far. I want to make it
like old PP environment, size should be different.
which side?
First right. Good. That should be different in the OLPP.
Okay, yeah, that's what I told you. Some root for that, correct? So you have to see that how often the changes are happening. Whenever the changes are happening, if the action size is too small, you know that the migration change, so many issues will be there, correct? So we need to go for the sum root. That's the reason we have what are the AU size? It's a multiplication of the external size also, correct? In database, extend that there are some, we are created, and same thing concept here also, correct? Then we have to apply our database thing. That how to do the database, big extent and small extent, the same concept here also. So we never work with a single AU across all the disk group, okay? We will create a dissimilar, different disk group with a different AU size. Correct? Again, one more point is that one disk group can have a multiple AU size. One disk group can have a multiple AU size. Fine? Sorry. Not AU size, multiple algorithms. One disk group can have multiple algorithms.
Sir, according to fine grained 128K would be written once, right? So once we have 200 KB file to be written, we have already written 128 KB on the first disk.
200 minus 128 percent.
78
remaining next disk.
But minimum should be 128.
Who told you? No. The slice ratio. The slice ratio is what? 120. Whenever you have 120, you will like next to 120, next. Correct? They are the slice ratio. Okay. So a single disk group can have a both. See, this is the scenario. What I can do is, I work with a single disk group. Okay. This is what one disk group. Data disk group. In the data disk group, we have a 3 disks. Perfectly alright? Then. And what I am doing is, whenever I am going to create a file inside, what allocation say? 1. Because, this one, allocation unit size, you are going to specify during the time of creation. So what is the allocation unit size? 1. So, whenever you are going to write here, all the data writing 1 MB. Which algorithm you are using? Force file. Okay, now I want to keep my control file inside. When I'm writing control file inside, since the control file size is less than 1 MB, what will happen?
Fine tune would be used.
No, less than 1 MB, it will not be fine, correct? So what I want to do? I want to use what? I want to use fine grain. But this already, the entire this group is already working with what? Whole file. At the same time, inside I want to use what again? Fine grain. That is possible. So what I can do is, within the disk group, I can create some template. So later I will explain this concept as template. So you can create a different template. One template I am creating using fine grain, temp1, temp2 I am creating using Bootstrap. You can create a different template where within the disk. Fine. Take an example. Now what I have done is I created temp1 fine grain. Temp1 fine grain. Temp2 Postgres. Perfectly right? Two things are right. Whenever I am creating any file, by default it will go for fine grain or post. Why? Because disk group level you mentioned 1 MB. Now when I am creating a table space, I don't want to go for Postgres. I want to go for what? Fine grain. So in that case, what I can do is I can specify, create a table space. Table space name, data file plus data bracket you specify. Template name. The template name temp1. What will happen now? It will inherit from where? From the it will inherit from the template. Correct? So it will inherit from the template. So later I will show you how the template works. But understood? So this is possible. So a single disk group can work with a different various.
You have to define the table space level which
You will have create explicitly specified which template you have used. But before that, the template has to be created in that case.
By default, the post.
By default, but control file by default using a template. So you can see the control file always will be what? Always will be fine grain. Data file always will be Postgres. But anytime you can change it. Okay. Anytime you can change it using an algorithm. You can. Clear this concept? Okay. So you understood what is a algorithm? How algorithm works. Okay. So the next one is serial views.
What's the location of these algorithms?
What is it?
No.
What is the location of algorithm? This is for the
These attributes must have been defined at
the software. It's a part of the software only, correct?
Okay.
Correct. So we are talking about the various algorithms. For example, we are talking about any type of things we are using algorithm. Correct? For example, when you talk about database level computing, we are using algorithm. Everything you are using algorithm. What algorithm or what is content guaranteed? No. If Oracle, repeating the content of the algorithm, what I will do? I will copy it and I will develop my own software. Correct? She's talking about the algorithm, how to
What I meant was is we have algorithm based on definitely their attributes must be there, right? I was asking for the location of those attributes that basically compose this algorithm.
You want to ask something like this. They written some algorithm post writing, whatever something like that. You want to see that how the algorithm works is stored over. You are defining an attribute or the attribute stored.
Attributes inside the algorithm. Please, I want you to so that I can see it.
Encode it. See, you can see which attribute I defined, which file using which attribute, which is the AU size, which algorithm it is using, how much size it is used, all the pieces of information we can get. But I cannot show you post-typing algorithm. This is what the post-typing actually also. It's better to contact the Oracle developer. I think they can, they can help you. Because they can reveal what actions they are doing. We told you calculation algorithm. Okay, the algorithm generated. I don't know what it is. They written the calculation. Stone is we discussed. Stone is shoot shoot or other. I can't say that what they written. These are the Oracle compiled entries. Change vector. We are saying the change vector. Rebuild of my contains the change vector. What's the change vector? I don't know. Right? The compiler of Oracle component. They never reveal it. So there are so many things which they hide. But Up to an extent, if you want to know the internal of Oracle, it is a very good idea. What is technology? You need some in-depth knowledge in the Oracle internal part. Inner part is not like this thing, but internal is how the change is works, how the logging works, what are the information that header part. If you want to go for that, there is a website available. You can visit this website. It's juliandive.com. So all the things, so many things will go like this only, but still you read.
Next
You love the place, man. You Romeo.
So you want to go for a break now or after?
After that. Yeah, immediately afterwards we will see. Now we are.
Now we will see that and what the failure to. Okay, but afternoon you can't sleep because so many new teachers are coming in the afternoon. Okay. No, sir, we are talking about a failure group. ASM failure group. Very important. ASM failure group. Take an example. This number 1, 2, 3. 3 discuss. Again. This number 1, 2. So total how many discuss? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 disk is ordered. So using all the 9 disk what I want, I created a disk group. Fine. So the disk group name is data. Okay. And what the system team given is one controller card, 3 disks. So C1. 3 discuss, C2, 3 discuss, C3. Because you know that the real world control card is very expensive, so they will share the parameters. So C1 is having very good bandwidth. So at a time, 3 disks can communicate. But they given only one control card. So this is the thing. So how many disks individually? 9. So according to our concept, whenever primary copy you are writing in one disk, secondary copy you will never write in the same disk, correct? Fine. So now what you are going to do, you are writing allocation unit of one primary copy here. What the secondary copy can write? 4, 5, 6, 7, 8 of the 8, correct? Yeah, 8. Any one of the 8 is correct. So it can write here, it can write here, anywhere it can write.
No, my question is, see, you can write the same control card, this what does it have, right? The control card board.
Yes, right. Okay, yeah, see. Fine. So just see that you are writing here. Okay, AU allocated unit one primary copy you are writing here. So where you can write the secondary copy?
2 or 3.
Any one of the use 2, 3, 4, 5, anywhere you can write it. So according to him, he is writing that AU1 secondary copy you are writing here. Correct. Good only. If disk 1 crash, no problem. Third disk is available. Disk 3 crash, no worry. First disk is available. What happens if the converter card goes? Primary copy and secondary copy. So in this case, what is the use of two-way memory? Correct. Even though you have a primary copy, secondary copy available, there is no use. So in this case, what you have to do, we have to go for a failure group. Correct. So this is very important thing in the real scenario. If you are not defining the failure group, it is the job of the DBA to define the failure group, not by the system people. They never do anything for it. Okay. So what we have to do is, we have to check with the system team how many disks are going to be affected because of the single point of failure. Whenever I am taking a single point of failure, it is not a hard disk to crash. It is a controller card, a switch or something. So we have to say that whenever any problem happens, a logical error happens, how many disks are going to get affected? How many disks are going to get affected? 3 disks. Which are the D1, D2, D3. So disk 1, disk 2, disk 3 will be getting affected if something happens to the control card. So we can say that these are the group of disks which can be affected because of a single point of failure. Correct? So what we have to do, we need to define a failure. So what is a failure group? Failure group is the group of devices which can be affected by a single point of failure. So if controller card 1 crash, these are the disks going to get affected. So what you have to do, you have to keep all the 3 disks and the group together using ASM unit to do it, and I am giving F1, phase group 1. Okay, and these 3 disks I am logically grouping together. This is phase group 2 and this is phase group 3. So I am going to create a phase group 2 and 3. So how many phase groups? 3 phase groups are available inside. Correct. So within the data disk group, 3 phase groups, the group of devices. Now, when you are writing a primary copy here, secondary copy never write in the same phase group. Secondary copy will write where? So, for example, primary, you are writing the AU primary copy 1 here, secondary copy never write here and here. Okay, secondary copy will write any one of another phase group. So, if you, in that case, if this phase also no problem, secondary copy will be available somewhere. So, if you want to go for a normal redundancy, how many phase groups you need? 2 phase groups minimum. Right? If you want to go for a higher redundancy, we need a 3 phase groups. Very important concept. If you are not designing properly, single point of failure will affect the primary copies as well as secondary copies. Correct. So phase groups. So these are the group of devices affecting because of the single point of failure. So we have to define that. Okay. So in ASM, I told you that free space allocation always in the form of an extender, correct? Always it is allocated in extender. Right? I told you, whenever you are creating a file created your space, your ASM coming and allocating an extender, and that extender is given to the DB. So in ASM, extend size, okay, extend size is equal to AU size. Okay, for first is 20,000 extend. What do you mean by that? Your AU size is 1 MB. What is the size of the extender?
1 MB.
1 MB. Correct. So 1 MB will be the size of the extender. For how many extends?
20,000.
20,000. For example, if the AU size is 4 MB, what is the size of the extender? 4 MB. Because the free space allocation here is always in the form of extender. Correct.
For 20,000 means for the first
20 means 0 to
20,000.
yeah, means that the first 20,000. 199 correct? 199 correct. So then after that, then the next one, correct? Next is 20,000. Next is 20,000. For the next 20,000, this will be equal to 4 multiplied by AU size. If it is 1 MB, 4. For next 20,000. 50. Next it will go. Means automatically it will grow. Okay. And after that, means after that means after 40,000 extend. After 40,000 extend, fine, means above 40,000. Because first 20,000, second 20,000. So after above, above 40,000, 40K, what will happen? 16 multiplied by AU. This is the problem if you are working with a bigger extent, correct? If you are comparing 16 MB as an extent, what happens? After some time, 15 multiplied by 16, correct? So, this is coming back. Okay, but this is not the AU size, so this is striping will be always AU size, don't worry. Extend size I am talking about, extender. Correct, your AU is not changing, AU size only, I am not talking about AU size, this is extend size. Okay, extender, one of extender. Whenever you are allocating one extender, here you will be allocating 16 multiplied by that much space you are going to allocate. Here you are going to allocate only 1 MB, correct? Here you are allocating bigger extender. So when the transactions are in progress, extend becomes bigger. You know the concept, no? PCT increase.
Yeah.
In Dynamics we have a PCT increase. What is PCT increase? First extent is 1 MB, second extent also 1 MB, third extent is 4 MB, then 8 MB, 15 MB, correct, no? PCT increase.
when you have percentage.
Different, yeah, percentage, whatever percentage you give. 50 English 0, 50 English 50%, 100%, okay, uniform size or whatever. Same.
It's not like uniform, it's not always uniform, it's self-wise.
It's a burden, no? Because assuming that every time you are requesting me, coming and requesting the and give me one X, assume that the exercise is always 1 W, what happens? Every time DB will come and say, give me one X, give me one X. Correct. Whenever the input output are programs, you are going to request the extender, then the extension has to give me take one X. Again take one more extender. When the segment is growing, I have to give a more extender. It's a convention, no? If so many data is coming like that, so many DM numbers are coming like that, it's a disturbance. So what will happen? So you take this many. Okay, now come to me. Once you finish, then you come to me. So I am giving a bigger assembly. So you will come to me only when after completing this. And the frequency you reduce. Which one? This is something like something like auto. Extend management auto is there. In database instance, we have a extend management auto. But here it is predefined. This is not predefined.
Why do we set the standard for 20,000 to be equal to 85 and 20,000? Let's have extents of multiple sites, and according to the requirement, it will be distributed in the.
You have control. You have a different distribution, different allocation details. Whenever you are doing the different allocation, the size of the extent is varying in one AU. The size of the extent varying in 15 AU. So you can indirectly control the extent size using which parameter? AU size parameter. Using AU size parameter. Okay. Okay, please go ahead. And everywhere it's working fine, no? Whatever you are input and everywhere. If it is not working, copy the image from me. You start from
A ver si yo considero que tengo que pagar frío. Oh, ¿cómo le quiero? ¿Qué ya hay? No tengo posible.
ଜାଣିକି ରହିଛି କାଳେ କ'ଣ କହିଦେବ ଲାଗିଲା ଶଶୁରାଙ୍କୁ କହିବ